Good morning, everyone, and welcome to today's KETIV Autodesk Virtual Academy, brought to you by
Adam Evangelista,
I guess, from KETIV Technologies.
Oh.
As well as myself, I'm Nigel here, application engineer at KETIV Technologies. I'm here with, as you heard already,
Adam Evangelista.
There you go, from KETIV Technologies. Adam, thanks for being here.
Yeah, thanks for having me. I'm glad to be back for another week, for sure.
Yeah, so definitely excited for today. As you can see on your screen, today is presentation date. Simplifying simplification, Autodesk Inventor.
I'm really proud of that alliteration. Thank you, Nigel.
Yeah, Adam's just one of those guys here at KETIV. So we're going to be going over some model simplification in Inventor. There's a couple of options to do so. We'll go over, a couple of those things. I'm sure Adam will explain a little bit more. How he discovered, it's like, hey, there's like 3 things. They do very similar things. Well, what do I use what?
Plenty of nuance for sure.
Yeah, and those are the kind of questions that we want to be able to answer for you all today. And so with that, I'll go ahead and let Adam run through his introduction. You guys can learn a little bit more about Adam before we get started. Let's get to it.
All right. Yeah. Again, thanks for having me back, Nigel. Glad to be back. Again, we have a new table here if you haven't noticed, but don't worry, it's a new set with the same mission. Empowering today's manufacturers and innovators for a better tomorrow. So let's get right to it, right? Let's talk about simplification and what that means for us, right? So simplification, we get a fair amount of questions about in the Lifeline queue ourselves, and it's something that not a lot of people understand very well, and that's why they have a lot of questions, right? And if you guys saw my previous video about design views, essentially they're really good for supplementing your current workflows. And so it's not necessarily essential in the same way that you want to, you'll be able to do all your work without it. But I guarantee, and that's my promise to you guys all today, if you understand design views, if you understand simplification, you're going to be able to speed up and streamline your workflow for the better. Okay, so what is simplification? Let's get into it, right? Quick outline for today. Like we said, we're going to do a small introduction. We're going to go into the different methods of simplification that are available inside of Inventor. There's going to be the shrink wrap, the derived part, and the traditional simplify tools. It's a bit of a legacy thing now. And then we're just going to wrap it up in a nice little summary, followed by a Q&A. Okay, that's the nuts and bolts of it. Let's keep going. A bit more about myself, Adam Evangelista, KETIV Technologies, application engineer. Been here for about 6 months now, about having a good time, learning a lot of stuff. I'm going to have a mechanical engineering background, and I have some small fabrication experience from my last job at a makerspace, which helps me help you guys with your questions about manufacturing and design. So again, happy to be here talking about some new tools available to y'all. I wanted to also share my coffee preference here. I like my coffee black, essentially. Nigel, how do you like yours?
Definitely not black. You're drinking creamed coffee right now.
It's for the sake of the conversation. Thank you, Nigel. But my point is, I prefer coffee simple and clean, which is at once a great theme song, and 2, the topic of today's presentation. That's right. We're talking about simplification. And so simplification, in a broad stroke, simplification is about reducing complexity, which is kind of obvious, right? Specifically in the context of Inventor, however, complexity kind of manifests itself in complex assemblies, right? As 1, the number of parts that you have, and 2, the level of detail of your geometry and representation, right? And so when we say simplification, Autodesk is referring to a collection of methods available in Inventor for reducing that kind of complexity, right? So 1, reducing the number of parts, or 2, reducing and simplifying the geometry and simplification, right? And I had this nice little graphic over here, if you guys will notice on the right-hand side of the screen. Again, complex assemblies kind of come in, right? They're this collection, amalgamation of a bunch of different parts and their relationships. They're kind of unwieldy, kind of hard to work with, really resource intensive. But through simplification, you could convert those complex assemblies with lots of moving parts into a very simple, very clean, singular part, which is a lot easier to work with and less resource intensive, right? Speaking of resources, we're talking about context now and why we're even interested in simplification in the first place, right? And so it lets you reduce complexity, right? And it's kind of ironic because CAD is usually about adding more detail, right? The more detail, the better, especially in the manufacturing and design environments, right? But there's plenty of situations where added complexity isn't beneficial, right? And so one of the main reasons we get calls on Lifeline, for example, are for Inventor performance issues. And a large part of those cases could be attributed to poorly optimized, poorly designed parts, right? And so they're having bad performance, bad assemblies. They're really complex and really unwieldy, like I was saying. And so complexity and simplification is going to help alleviate that process and let you have assemblies that represent themselves without being too complex. And so, you can imagine if you're working in you're like a AEC contractor or something like that, you don't need to send the fully developed part with the full model tree to just be a reference part inside of the final architect's drawing or something like that. And in the same breath, you don't need all the same parts from a reference model to go into your vault or something like that, for example. So helps with performance. We're also interested in protecting proprietary information, which is one of the other main reasons why you may be interested in simplification, right? You don't want to be giving all those sensitive information over to people that might use it, incorrectly or improperly, right? So if you want to send a part to a manufacturer or something like that, you don't want to give them all the details. You can send them a simplified part instead for reference. And that's the other major use of simplification. And there's some other motivations here too, which I won't get too into. There's like some regulatory compliances which may come up if you're in the AEC world, and there's also some applications in simulation which you're interested in. And I actually borrowed a slide. This is the smallest slide, but I did borrow the slide from our simulation expert over here. And simplification shows up a lot in simulation because, again, you want to kind of reduce the resources that your simulation is taking while preserving the fidelity of the results, right? And so this is an example from Fusion 360, in fact, where they're talking about defeaturing and simplification. The idea is still the same, but the original model had a bunch of surfaces over here, and using the simplification and defeaturing tools, they're able to get a much lighter model with about 5,500 surfaces instead. And that, again, frees up a bunch more resources and lets the simulation go a lot quicker, right? Again, if you're interested in that, I mean, we have AVA, we have plenty of people on staff that can answer more questions about that, but just wanted to shed some context on why and how simplification is used. Okay, next slide. And so that said, let's jump right into it. I mentioned 3 different simplification methods. I'm going to start with Shrinkwrap. I'm going to go to derived parts, and then finally I'm going to end on the traditional simplify panel that used to be in there. And so I'm going to go ahead and tab out to my Inventor. There we go. And so when I was developing this presentation, I was trying to figure out like what kind of sample I wanted to show everyone. And I figured, what does everyone want to simplify? What is everyone, asking about all the time? And so Nigel, what do you think we're going to try to simplify today?
Some large assembly of some sorts.
Oh, see, that's a good guess, but you know what? I have something even more valuable than simplifying large assemblies for performance and streamlining. We are going to, in fact, simplify today life itself. And so that's a joke, of course. Everyone wants to simplify life, but really we're going to simplify the buffer prep skid from the Inventor samples in 2019. Just as exciting and just as relevant to everyone's life, I'm sure. If you guys are familiar with the Inventor samples, you could pull this up from your Inventor samples that you can download online. So Autodesk, samples, models. This is going to be under the tube and pipe section specifically if you're interested in following along. Buffer prep skid, and I'm going to be using this assembly right here. Okay, cool. And so, yeah, we chose this model specifically over the regular life model just because I think this is an interesting model that has kind of demonstrates the conflict between scale and fidelity, right? And so essentially what happens, we have a large building scale, room scale model over here, right? You could look in any direction on this model and see literal, tens of feet in any direction, right? And yet you could zoom into any of these parts and you could see a lot of great details, right? Look at the chamfers on this bolt over here. Look at these grooves on this little knob thing right here. There's buttons that are rendered over here. This whole little gear section, this meter is a bunch of fancy fillets and everything. This whole tube and pipe assembly is over here hanging out with all of these individually modeled bolts, more chamfers, more edges. There's some embossing over here. Man, that's great. There's some even like millimeter scale holes over here. And again, this is all done with good intentions, of course, right? You do need those details at some point, which is fine. But let's say all I really wanted for this assembly was to be a representation in my factory layout. Do I need millimeter scale holes to be rendered in my drawing? The answer is probably no. And again, just keep in mind the context of what we're doing this for. And so the main goal of today, I want to take this particular assembly. I'm going to focus on this large vessel here. I want to simplify it down so it doesn't consume as much computer resources and doesn't render as many parts, and your computer is free to do more things. It's not loading as much, and we're going to go from there. And so that said, I'm going to go ahead and open up this part over here. We have a brand new assembly looking cute. Okay, and what are we talking about? Shrink wrap? Talking about shrink wrap, of course. And so over here in the assembly tab, right, you're only going to see the simplification options under the assembly tab inside of an assembly. And if you don't see simplification, you could go ahead and open up this little quick select menu here and make sure that your panels are enabled here. In this case, simplification. Good stuff. And so I'm going to go ahead and just start by pressing shrink wrap, right? And again, the main goal of shrink wrap and any of these simplification tools is 1, to reduce the number of parts, and 2, simplify the geometry and representation, okay? So this first tab right here, components, is going to be concerned with the former, right? The first section over here, we have representations, right? So if you had different levels of detail or different views that you already had saved on your part, you could access them here. Nothing too interesting here, but in this case, you know what? I don't want my final representation to have content center parts. That's great. You can already see our part count dropping down here quite a bit, which is great. There's another option over here for removing parts by size. This is kind of a finicky one too, but keep in mind that this number that you're inputting here refers to the diagonal of the bounding box that's going to be used to filter parts out. And so if you can imagine a square box with, you know, like 50 millimeters diagonally across, that's what it's going to remove from here. And so you can see some things already coming out there and there. So since I've done this before, I'm going to go ahead and crank it up to 200 just to see how many parts we could get off there. And that's looking pretty good, right? So those kind of little details, not that important to me, especially in my final representation. So it's looking pretty good. But moreover, you could individually select which parts you want to include and exclude here. In this case, you would just go ahead and click this red arrow. You could choose to get rid of this guy and this guy over here. And maybe there's something on the bottom that I want to get rid of as well. And we're looking nice and clean, you know, we're looking pretty good. And so that said, those are the components I decided to include and exclude. You could also choose to view some other stuff. So you can see the parts that you just removed over here. You could choose part priority, or if you want to choose the number of instances, that's what this checkbox is here for, right? And if I uncheck that, you can see it's only one of the legs now. That's it. Moving on to features, right? We're going to be removing and simplifying features in this tab. And so what we're talking about over here, you can see there's space for removing holes, removing pockets, removing fillets, removing chamfers, right? And again, you get 3 options for each of these guys here. You can either just leave them be as you want. You could select to remove them all as you desire, right? And you could go ahead and press preview and see how that turns out. Oops. And this is a thing that comes up as well. I'm missing a bitmap here, so I'm going to go ahead and skip that. But go ahead and run the preview. You can see all the holes that we had earlier from removing parts are now going to be excluded as well. If you want a bit more control and finesse on that, you could choose this third option here, which allows you to choose the max diameter hole that's going to be removed here. Okay, like if I typed in 50 again, for example, only some of these holes are going to disappear, right? I'm going to go ahead and, in the sake of making it as lightweight as possible, I'm going to choose to remove all the holes. I'm going to choose to remove all of the fillets, all of the chamfers, and all of the pockets. Okay, and so I'm going to go ahead and hit preview, see what's going on. Looking pretty cute, gotta say. And then finally, there's some other stuff down here as well too. And if you're into like some more complex models, or if there's certain parts you want to preserve, you could detect the features themselves, which parts are going to be filtered or may not be filtered, and you could choose which particular one you want to preserve. Okay, nothing I'm that interested in today, of course, but let's go ahead and go on to the last tab, create. Again, the main goal of Simplify is to make a singular part from a complex assembly. And so you're going to get the normal stuff here. You could go ahead and choose the new part name. Let's go ahead and call this AVA test 1. And you could save it as an IPT or sheet metal part, and you could also choose the file location. I'm going to save it somewhere where you can look at it a bit later. So I'm going to put it in the top level of the skid folder, Coolio. Go ahead and save that. And what's nice about Shrinkwrap is that you also have this BOM structure input as well. And so oftentimes if you just want to use this piece for reference, right, you could go down and use it for reference. It's courtesy to your BOM managers over there. You could make sure that it's not going to be cluttering up the rest of your bill of materials and everything from there. And finally, we have style down here, and this is going to dictate the kind of solid that the resulting IPT is going to be, right? And so you get a few options right here, right? So this is normally what people will see. You could do a single body without seams. You could do a single body with seams. You could do multi-bodies, or you could do a composite surface. I'll tell you guys right now that the composite surface is probably the best option for you if you're looking to make the smallest part possible. Although in the past, the Simplify tool only allowed you to use the first three, and then if you can't use the composite surface, the single body without seams is your next best option. So let's do that. Let's do like composite. And finally, there's a few more options here at the bottom as well, right? We could break link. These parts are associative with the parent assembly, and so if you make changes to the parent assembly that this part's derived from, that'll reflect back in here, which is great. I'm going to keep the link there for this matter. It doesn't matter too much right now. I'm going to fill internal voids, remove internal parts, and use the color override from source components. Okay, and I'm going to go ahead and click OK. And do I want to calculate mass properties for level of details? Not a big deal to me, TBH. Beautiful. Okay, and this is going to be the resulting part here, right? I want to draw you guys' attention down to the two numbers in the bottom right of the screen right here, right? So again, we talked about these numbers in my design review presentation as well, but the first number there is the number of parts that are rendered on the current screen, and then the second number is the total number of parts that are rendered, the unique parts that are rendered across all three screens here. So you can see if I get rid of life over here, that 56 number is going to go down to 55, and this part still represents a single body that's going to be rendered. So that's shrink wrap. That's a good time. That's going to help you get a nice, simpler model, right? But you know, this is all fine and dandy. If you want to make a new assembly, you could place this part into a new assembly willy-nilly if you want. But ultimately, what my goal is to have a good representation of the same boiler in my top-level assembly. And so I'm going to actually go back to my boiler assembly right here. There's two shrink wraps here, which is I always thought was kind of curious because we're going to be talking about shrink wrap substitute. Shrink wrap substitute is really similar to regular shrink wrap. You could click on it, you're going to see the same exact options as the regular shrink wrap, but the only real difference here is going to be that we're going to be able to make a level of detail and substitute it in with this. Okay. And so I'm going to go ahead and go through this one more time. Let's see, create. I'm going to name this AVA test 2. I'm going to choose the same file one more time. Having a good time here. Oops. Tube pipe, OPT, right there. Save. Composite surface, reference, coolio. I'm going to click OK. Okay, and so notice this time I didn't open up another part, right? I didn't really make another part here. What I really made is a substitute level of detail, okay? And you can see that over here in the model screen. And what that means is essentially I could go back to my assembly over here. Oh, let me go ahead and look at this first. But you can see over in the representations, this manifests itself as a new level of detail. You'll see it right here at the bottom. There's a brand new logo versus the previous stuff here. And this is essentially going to be another level of detail that you could use for this assembly, right? And what's unique about this, right? Level of detail is cool because you could kind of control which parts are loaded and which are unloaded at different save states, essentially. And while these other regular levels of details kind of represents the whole top level assembly itself and different parts in that assembly which can be loaded and unloaded, this whole substitute level of detail, it's just substituting the entire assembly with that derived part that we made earlier. So this is a single body right here, again referencing this number at the bottom. So that's great because what could end up happening, we could go back to our top level assembly, and now we have a boiler assembly right here. We could check it out. We're going to go down to representation and level of detail. See where I'm going with this, Nigel? Go to level of detail over here, and we're going to see we have a new substitute level of detail available for us. And so let's go ahead and select one of those guys. I'm going to go ahead and click OK to save all those parts. And now this part is going to be the representative derived part that we made here instead of these fancy ones with all these extra parts here, right? again, we're largely preserving the, the representation of the boiler while reducing the number of parts. And so I'm going to go ahead and jump back over here and look at the master part. Again, keep an eye on the number of total parts rendered down here. We're at about 1294 right now. I could go back to master over here. Total number of parts jumps back up to 1486. And so this substitute level of detail lets us unload about 200 different parts from this original boiler assembly right here. And so it's pretty significant, even just this one assembly right here, right? But you could imagine if each of your assemblies that you're working with, if you include a step to develop a substitute level of detail for each of these sub-assemblies, you could essentially have a brand new kind of lightweight level of detail associated with the top level assembly, right? And so you could go from 1400, not just down to 1200, but hopefully down to even lower than 500, I could imagine, with this many parts here. So that's the idea, right? It's all the little decisions that kind of add up and kind of help you save resources here and there and ultimately improve your workflow.
Yeah, a lot of these cases, right, all you really need is the actual geometrical representation of what your assembly looks like, right? You don't need it in terms of what it looks like in form of function itself, but you need to understand how much space it takes up on the floor. For example, say this thing is in the corner of like your giant facility. Say you have like 10 skids similar in size to this and functionality, and you want to do like a factory layout, like that would suck. Just to be blunt there, is to load up, what was that, 1400 files? Load up like 15,000 files.
Exactly.
In memory to, do a factory layout. It's gonna, unless you've got some awesome computer, it'll probably be super slow.
Exactly.
So yeah, you just need to know how much space this thing takes up, right? You don't want things to collide with each other. Maybe you're trying to figure out if you want to place it on, this wall or the other wall. You just need to see, do I have a walkway? Do I have space or not for this? And that's really, really key and like a big workflow improvement for a lot of people when we show them tools like this.
Yeah, definitely. And so I definitely appreciate the context, right? Because again, it's these little things, and ultimately you have a lot more control over the complexity and how much resources your parts are controlling, right? And that's always going to be a good thing for you guys, whatever you guys are trying to do, whether it's factory layouts or sending out parts, or even like, you could imagine if you had all these parts on a network drive or something like that with a really slow connection, saving a lot of time ultimately, which is a good thing for everyone. And so let's jump back to the PowerPoint. Let's see what else we got there. A shrink wrap again. It's really good for, again, simplifying large assemblies, bringing them down into a single part. And the substitute function is probably the better of the two, in my opinion, just because you get to attach that level of detail in that simplified part to the assembly itself and use it as a substitute in other assemblies. Yeah. I really like that. That's good stuff. Big fan of design views myself.
If you need to send it to somebody, probably the regular shrink wrap is going to be better. If it's, you're generating the shrink wrap so you save your IP, you don't necessarily want to show all of the details of your machinery to, say, someone purchasing your stuff, right? Maybe you just want to send them a shrink wrap of that so they can't necessarily see the internals, so on and so forth.
Yeah. I mean, if you guys have ever grabbed any parts from online, like from GrabCAD or GrabCAD or anything like that, you'll notice that a lot of times they don't come with the direct source files, exactly, just steps or OBJs and stuff like that, for the same reason, right? The next thing we're going to talk about, the other method that's available in contrast to shrink wrap, is the derived part functionality. And derived part is, again, it tries to achieve the same goal, essentially. It can achieve the same goal as the shrink wrap command, but ultimately the derived part is a bit more granular in like the options to include and exclude parts from your assembly. And it is meant, I would say probably the biggest distinction is that derived part is meant to be a springboarding for new parts, essentially, right? And so there's going to be a lot more options for developing how the resulting IPT comes out and how you're going to be using that in the future, okay? And so, yeah, let's jump to it again, right? Let's go back to Inventor right here. I'm going to go back to my vessel assembly right here. I'm going to go enable the master level of detail. Good stuff. And the first distinction, right? You're going to be in an assembly like me, and you're going to be looking for the derived part button. It's not going to be there because derived parts start in new parts specifically. I've made this mistake many times, and You're only going to see derived part once you're in a new IPT like this. Go under Manage, and you're going to see the derived part button under Insert. Okay, I'm going to click Derive. It's going to ask me to choose an assembly to derive from. Okay, so it's kind of backwards. See, where we were looking at the assembly last time. We're going to be starting from the part file and pulling down the assembly into us. And so let me just go up here. I'm going to go over to vessels, and I'm going to pull out the same assembly that I was working with, which is this 2,500 liter vessel right here. Changes have been made. Let's go ahead and save that. Right away, you're going to get a brand new dialog box with 4 tabs this time instead of 3. And so that's a good time. And you'll notice right away that there's not a lot going on here because I have all content center suppressed. It's going to pull in the last active level of detail that you had. And so I'm going to go over to representation. Again, notice we could play with representations once again. So if you want to adjust it according to design views, positional views, or level of detail, you could do that here. And I'm also going to unlink this associative part right here as well for reasons that will be clear shortly. I'm going to go back to this first page, and you're going to see this whole page got kind of populated over here with a whole design tree. And so again, this is going to be a whole list of all your different parts in your assembly and everything like that. And there's going to be a few more colors here. Again, we're going to see derived style again, and we're going to see the different same buttons that we saw in Shrinkwrap. Right, we can make single bodies, multi-bodies, composite bodies. I'm going to go ahead and show you this first one first. And we also have this new bar here called status, which shows a bunch of colored icons and stuff like that. And so these colored icons right here kind of are going to help us exclude and include stuff here. This first tennis ball looking one, that's going to be parts that are included in the assembly. Okay, this gray one right here, this is going to represent parts that are going to be excluded from the assembly. So I don't know, maybe we'll do this one first. Going to be excluded from the assembly if we wanted. That's cool. If I keep clicking over to the next one, there's a red option as well, which is going to allow you to subtract the selected components. So if you're familiar with like the Boolean operations, for example, you could use this part to subtract from other parts inside of this assembly, which is kind of cool, right? And then finally, you could also use this green option here, which is going to develop an envelope. So it's going to essentially surround the part with a very similarly sized extrusion, in this case a square, and it's going to replace it all with a big square instead. And so that's kind of nice again if you're looking for representation, or if you're just using it as reference, that's an option for you as well. And then this blue one is another similar Boolean operation where it'll allow you to intersect the selected components for the derived part in the end. Okay, and so that's all fine and dandy. So I'm going to go ahead and go through. I do want a composite surface like we used last time because I want it to be as lightweight as possible again. And I'm going to go ahead and select out some stuff down here that I don't want to include. You know, maybe I don't want this guy or this guy or this guy. Maybe I want to work on this guy. You could also open up these assemblies and look a bit closer at the individual parts, right? Maybe I want to replace this whole thing with a bounding box over here, let's say. Maybe that'll be a good time. But again, you kind of have a bit more control over, you know, what kind of geometry gets added and what doesn't get added. And with these additional options over here, right, you get these extra Boolean operations to kind of tailor your derived part to be something that you want to be working off of in the future. Okay. That said, let's go and leave that bounding box there. Have a good time. I'm going to go to the Other tab now. And this is going to be the biggest distinction from the Shrinkwrap command here. You're going to see a really similar feature tree over here, but instead of the individual parts, you're going to actually see sketches, work geometry, imates, and parameters, right? So this is going to be essentially all like the sketching and work geometries and reference geometries that are associated with these individual parts, right? So if I want to bring over a really useful sketch or really useful construction line that I made in this particular part, then yeah, I could bring it over if I want. And notice there's only 2 options here for include and exclude. And so if I want to, you know, include surface bodies or not include this stuff over here, I have that option too. And so again, this really speaks to the point of derived part, in that you could kind of bring over old references that you're using in the original assembly. You could do some more Boolean operations to tailor the derived part a bit more. It's going to be a better springboard for you to make new parts from this, as opposed to just making a simpler reference a la Shrinkwrap, right? But kind of an interesting point to make. I appreciate that a lot. And so representation, like one more time, like we mentioned, there's still more options yet over here as well. And so, You could also remove parts. This is kind of similar to like the removing features in the shrink wrap section. You could remove parts by geometry visibility and remove parts by size, if you remember that part. These are kind of finicky, if I'm being completely honest. You'll see that the metric here is actually a relative percentage, which is kind of hard to gauge and understand and really use. But I'm not going to use it because I don't want to mess up my part, because I don't have too much control over this naturally. So I'm going to uncheck those, but feel free to play around with those if you so desire. And there's also a hole patching function here, so I'll go ahead and patch those holes. And these two options are interesting as well. Scale factor, you could make your size bigger or smaller accordingly, but probably more interesting to some people, you could do a unit conversion here as well. And so if your particular assembly was in like inches and it needed to be in millimeters, you could apply that scale factor here, hopefully. And then you could also make mirrored assemblies as well. So you know, left-hand parts, right-hand parts is kind of available here as well. And so again, the idea is you're kind of springboarding to new assemblies, essentially, to new parts and assemblies, right? And then again, a few more options here, like reduce memory mode, color overrides, and internal voids, okay? I'm gonna go ahead and click OK, see how this turns out for us here. Here you go, gonna load a little bit.
Yeah, note like after this all loads, you derive the assembly and you still end up with one part, right? You're not deriving an assembly and getting another assembly, something like
Beautiful.
Something like you would get using the one of two things, right? The design assistant or like the copy design functionality in Vault. So they have different uses. When you're looking at the copy design functionality in Vault, you want to carry over the entire assembly structure, but maybe replace a few components. In this case, we took an entire assembly and we turned it into we got, you know, considerably more options when we were doing the simplification, and we generated a completely separate part from it, as opposed to having that same assembly and replacing some of the components. So just a couple of things there to denote the difference between something like this and something like copy design or the design assistant itself.
Yeah, so definitely a lot of nuance there. And you can see our new part with our cool bounding box and all these great work geometries and stuff like that. It's a good time. A new part that you could use in your new assemblies and everything like that as you would need. Go ahead and save this guy right here. Let's do Ava test 3 here. There we go. Go ahead and click save. Yes, thank you. And so now, let's see. And so yeah, that's essentially derived part, right? That'll allow us to derive parts as needed there.
Yep, and you can see we still have all of those like work planes and all that fun stuff there that came from the assembly itself. So just keep that in mind.
Good stuff. And so, yeah, that said, that's derived part. Again, it's probably the more granular than shrink wrap even in terms of choosing, you know, what you want to include and exclude. And you can see there's a bit of overlap there, but still a bit of nuance. So just be aware of what you want. I personally prefer shrink wrap as well, but it floats your boat. The last command we're going to talk about is the traditional simplify panel. So if you've been around Inventor for even a few years, like I think the last time I saw the regular simplify panel was in 2016 build specifically. But if you go to the simplify section of your assemblies tab, you're going to get these 3 options down here, which used to be their own standalone panel. This is probably the least amount of options and probably results in the largest IPT compared to the other 2 methods, but it's still quick and still relatively easy. And so I just wanted to walk through that really quickly as well while we have the chance. And so I'm back here. I'm back here with my beautiful assembly. We have our simplification section right here. And the kind of distinction with the traditional simplify option here is going to be, you're going to be creating parts off of different design views, okay? Again, shrink wrap, we kind of use shrink wrap to make level of detail substitutes, but for the traditional options here, you're going to be creating parts based off of the design views, okay? And so I can go ahead and click simplify view here, and it's going to prompt me with this nice contextual menu right here. And this is going to be really similar, again, to the previous 2, where, again, the first thing you're going to do is decide what you're going to include and what you're going to exclude. You can go through here, click on the stuff that you want, that you don't want. You can also select part priority, too. If I want to select the whole component in this example. And you can go through and click that there. Again, it's kind of a bit more tedious than the other options here. I'm going to be able to select all the components. I'm going to click that box right there. And so that's one option, right? So kind of tedious, kind of picky, but you know, pretty straightforward. Go ahead and click OK there. And again, this is going to manifest itself as a different design view over here in your product tree and in your model tree over here. And so this is a simplified view. And if you want, you could also define envelopes, which is always a good time. And so you're going to select that option. You're going to select a part that you want to replace with a bounding envelope, like this particular meter looking thing. And you're going to see the actual outbounds of the box that's going to produce itself, right? And you could adjust that accordingly, make it bigger, smaller, whatever you want. Doesn't even have to be square. It could be a bounding cylinder if you really want, but I do want a square today. So let's go with that. And you could go ahead and click OK there. And so now, yeah, again, it's a bit simpler than the last one, but the final step after you have a design view that you like, that's simple enough, you could also define envelopes to make it even simpler, to simplify geometry and representation. And finally, you could go ahead and create the part itself. That's what I was talking about here, where you only get those 3 combined styles, right? The newer stuff has that extra composite feature section over there, which is, again, pretty useful. This part still produces a pretty large IPT, but this first option here is going to be the lightest of these 3 here, which is single body with seams merged. Okay, and let's do AVA test 2. Oh, I guess we're on 4 now. And let me make sure this is in the right place as well. Okay, save. Okay. Oops. And again, so here's a brand new IPT that was derived from a view rep, right? And so that's again what the traditional one does. And I mean, it seems like I personally prefer Shrinkwrap in the derived part just because there's a bit more utility there, right? But I mean, simplification, if you have a design review ready, if you just need it quick and easy, it's there. It's there for you guys for sure. And so that said, let's see. That's the traditional simplify panel for you there. And I did want to go through a quick summary. We can go ahead and check out the size of these parts actually while we're in here. Let's see. And so, well, let's go to the section over here. I'm going to go back to my, where am I? See. Let me go back to that same folder with my other drawings there already. Let's see. There we go. Models. Let's go to tube and pipe. Did I not save that? Hang on a second. I'm going to go ahead and save this. This is kind of a weird quirk when I was testing this earlier, but if you don't save these, they don't actually show the size here yet. But I'm going to go ahead and save this one more time just to update the properties. And I'm going to go back over here. And now I have 2 through 3, 2 through 4, right? The first one, again, was the first one that we worked on, which is, again, about 407 kilobytes right there. And you can see the derived part, which was test 3, is going to be 22.5 megabytes. And the AVA test is going to be 2.3 megabytes. And so you can see you probably had the most control over the first IPT, which was made with the shrink wrap. That's a good time. So just keep that in mind. That's the kind of resulting parts that you're making there. So you have a bit more control over that size and everything like that.
Yeah, keep in note too, like the file size could be one thing, but if it's associative to the other models, it's still going to be heavier, right? Because essentially it's going to be looking at that other model, making sure no changes were made, or if changes are made to that model, right, it has to drive all of the changes downstream. So if you break those links, it'll be faster.
That's a good point. Yeah, definitely. And so so keep that in mind. Again, you do have a lot of control over the size of these parts and the complexity of these parts and the number that are going to be loaded in these parts, and that's what simplification is all about here. Now, that said, those are the 3 commands that we were going to talk about today. Just a quick summary. Again, this is what I've taken away from this whole process. All 3 methods get you a simpler, lighter IPT file, right? Shrinkwrap is probably good for general use, optimization, streamlining, and obfuscating proprietary information for sending and sharing parts everywhere. Drive part is good for shrinkboarding parts as well, but will do just as good a job as Shrinkwrap at simplifying assemblies down. And Simplify is okay, but it is quick and easy, and it's just as accessible as all the other tools here today. And as always, I mean, just be safe and be aware of the context that you're using all these tools in, and you have a lot more options and control than you do. So if you want to call in, feel free, of course, no problem. Happy to help.
Definitely. Thank you all for being here today, Adam. Definitely thank you for being here today. You're here every day. But maybe not in the AVA room. So thank you all for being here. Have a great rest of your day. And then those of you who have Friday off, have a great weekend. We'll talk to you all soon. Bye-bye.